All right. So I'm going to go ahead and assume that everybody in this room lives in California because we're all sitting here today. And what that means is that pretty much everybody's felt the effects of wildfire in some way. And whether that's school being canceled due to smoke or bad air quality or those crazy orange skies we all saw in 2020, everybody's lives have been touched by wildfire in some way. Now, it's not a new phenomenon, and I want to dispel that notion immediately. Wildfires always existed in California, and there's a lot of ecological systems that rely on the presence of fire in order to function. There's certain pine species that won't even open their cones unless they're subject to extreme heat. That said, it's gotten a lot worse, and that's pretty clear. We've been seeing a lot more news headlines about record-breaking wildfires, about vast swaths of forest over California, old-growth forest getting burned down. So it's clearly an issue, something that is new, something that there's something changing about it. Anyway, California is a Mediterranean climate. That means we have wet winters and dry summers. And those long, dry summers are what we're known for, right? But it also creates the perfect breeding ground for fire. It creates this tinderbox environment in forests all over California so that a passing dry lightning storm could ignite it, or somebody's carelessly left on campfire could start a huge raging inferno. And this is because of a couple of reasons. First of all, historically, forests would look like this. Wildfires would periodically burn through. There was nobody there to fight them, right? So fires would rage through forests all the time. But rage is a little bit of a strong word because they were a lot tamer back then. Because there was more fire, there was no underbrush. There was a lack of fuel. And because the fires came through quite often, actually, you can see there's a lot of spacing between the ground and the trees, and there's very little fuel near the ground. But after 200 years of wildfire fighting, we're left with, you see fire spreads laterally. We're left with things called ladder fuels here. And because no fire comes through, there's a lot of dense understory plants that are allowed to grow in, and fire can actually gain vertical motion and spread to the top of the crowns of the trees. And once it gets here, it can easily spread from tree to tree, because as you can see behind, there's very little motion down here. It's hard for the trees to actually connect and for fire to spread between them, but once it gets up here, the forest is done, right? So this is the aftermath of a healthy burn. This is actually a forest in Oregon where there's experimental strategies being implemented, and you could see the fire came through, and it's mostly relegated to this bottom 10 feet of the forest. It's charred here. The shrubbery is burned down here, but if you see in the background, there's still a lot of living trees existing, right? And cut to 10 years in the future, this is what that forest might look like, right? There's a lot of spacing between the trees here. There's, hold on, sorry. There's a lot of spacing between the trees here. Sunlight can easily penetrate to the forest floor. The forest is largely very healthy. There's some, cosmetic burn scars on the trees, but that's about it. And the thick plating of the bark on the trees in the bottom area protects them from fire. And so the tops of the trees remain healthy and the forest can stay alive. Now, this is the aftermath of something called a crown fire. When there is ladder fuels in these tinderbox forests, this is what can happen. You see the fire spread to the top, the overstory, the crowns, and the entire forest is gone. And 10 years later, it might look a little bit like this. Now, this is an example. This is the Dixie Fire in 2021. And this is a picture 2 years later. But as you can see, there's almost no regrowth. It's dead. This is a burn scar, and this prevents a multitude of issues. First of all, there's no forest left. And second of all, it opens the possibility for when catastrophic rainfalls happen like this winter, all of this can get washed away and prevent there ever from being a forest that recovers. So before I continue, there's a couple unique traits of forests. And when we're talking about climate change, forests are particularly important because they're a unique place that can store vast amounts of carbon like very little other places on Earth. Trees sequester carbon, put them in their roots, in their trunks, in the soil, and they can add carbon to themselves yearly at a very, very quick rate, faster than, say, grasslands, right? Faster than this here. And without a forest, there's no carbon sink here. When this all gets burned down, the carbon gets returned to the atmosphere, never to be sequestered back into the ground again. Now, there's a few ways to mitigate this. The first method is something called forest thinning. And what that requires is foresters coming through and removing a portion of the trees and removing the tree's lower branches. And what that makes it hard to do is, like I said before, for the fire to get from the ground to the canopy up there, to the crowns of the trees, because, like we said, the thick plated bark down here protects the trees to some extent. The second method, and by far the most important, is called prescribed burns. And what that entails is firefighters and foresters actually purposefully lighting the forest on fire in a way that would mimic the natural wildfire response. And it creates an environment here, like you can see down here. This is all charred here, but these trees remain living. It burns the understory here in a controlled way, and they control for all sorts of things like temperature and humidity. They do it on the perfect day. But all this stuff right here, all this ladder fuel is eliminated, and the trees in the overstory remain intact and alive. And when this is coupled with forest thinning, it creates an environment similar to what used to exist in a lot of forests in the West. And so these two methods are mostly experimental right now. They're not being widely implemented in national forests, public lands, private lands. They're being used in some places, but I wanted to see definitive evidence for these methods working. So I looked at a study, and this study took place in Flagstaff, Arizona. I know it's Arizona, but you can see the environment is actually really similar to California. Oh, you really can't see that right now, but it's a lot of pine trees. It's similar to environments in places like Tahoe. The forest composition and the yearly temperatures are similar to like Truckee, right? That's an area that sees wildfires now, and it's something that we can compare to California, right? And so what they did was they took a simulation of this forest and ran it over 100 years. And there was three different factors they were controlling for. They were controlling for, they had the control where they did absolutely nothing to the forest. They had thin only, where they thinned a portion of these trees out. And then they had thin and prescribed burn, which is both of the above mentioned methods. And what they found was pretty astonishing. So first of all, the first evidence they found was total ecosystem carbon. And what that means is that is, in a given area, the total amount of carbon that is stored there. That's in the trees, in the roots, the shrubbery, the trunks, everything. And what you can see is, logically, they lose a little bit. They take a little bit of a hit at the beginning when you burn some of the shrubs and and you take out some of the trees. But over time, by far and away, the most carbon stored is in the forest that was thinned and burned. And this is because fire is inevitable in the West, right? Like we just established, fire is going to happen. There is going to be things that we can't control for. Fire will happen. And in the event of that, forests are a lot safer when they've been burned and thinned out so that they can protect themselves from the risk of wildfire. The second factor was net ecosystem carbon balance. And what that means is the amount of carbon that can be added to the forest yearly. And as you can see, there's a huge, huge discrepancy between the control and the thin and wildfire. And this is due to the fact that more sunlight gets the base, the forest floor, and trees are able to grow more healthily. There's less competition. Water is distributed more evenly between trees. And so carbon is able to be added to that forest a lot quicker. The trees are able to grow thicker, they're able to go taller, and the forest overall is more healthy. And afterwards, after they found these results, they actually tested it in a real national forest. As you can see on the far right side, over here, this is no treatment. This is the area of the forest that was just left completely as it was after 200 years of no wildfire fighting. You can see the entire forest is pretty much burned down. There's almost no trees left standing. It's just charred, burned earth. And over here, what you can see is this is thinning, right? The fire is less intense as some of the trees are left standing, but for the most part, a lot of them are dead still because the fire still burned pretty hot in the underbrush. There was still a lot of fuel down at the bottom. And by far and away, by a landslide, this one wins right here. You can see thinning and prescribed fire was super, 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 super efficient at keeping the forest healthy and alive almost none of the trees have died. If you look really closely, you could see the bottom, the understory got burned. But for the most part, this is completely alive. This is completely left standing, and the forest is still healthy. In the case of thinning, if you're not able to do prescribed fire, some of these trees, if you look closely, are still alive. It's important to have living trees after wildfire because in order for a forest to regenerate, there has to be trees there to disperse seeds and to provide shelter from the exposure of sun and heat and snow and cold winds. And so this does work to some extent, but this is super, 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 super helpful. And this is super important in the grand scheme of climate change for a number of reasons. Like we said before, forests store more carbon. But when a forest is completely burned down, as I've said, there's no trees left to disperse seeds. And because the climate is warming, we're seeing more erratic rainfall, more erratic snowfall, so water storages are less predictable. Temperatures are warming for the most part in a lot of western states. And what that means is that the conditions in which the forest started at the last ice age are now different. Those forests, if completely reset, may not come back the way they used to be. And a lot of these forests may be desertified or turned into grassland like this. Because if there's no trees around them to shelter and there's no water left, there's no space for the young trees to come back. And you just lose a lot of total forest ground. And aside from forests being beautiful, they're super helpful for temperature regulation, humidity control, and obviously carbon storage. Now, this is super important to me because my family's ranch in Northern California was threatened imminently by wildfires between 2018 and 2020. We were surrounded in basically a ring right here. And when a spark flew over to our neighbor's property and burned 20 acres before it was put out, I thought I really had to research this, right? All these forests around here used to be thriving pine forests. And now we come back 3 years later after 2020, the most recent fires, and there's very little recovery in some places. Now, this is not the case in all the forests around here. There's some places that are recovering great. But for a lot of the region around here, especially in the oak woodlands, where it's super hot and they receive a lot of exposure, there's very little regrowth, which makes me super sad. But on the bright side, there's a few things being done in terms of laws. First of all, there's the National Prescribed Fire Act in 2021. What that did was increased funding for public lands to use prescribed fire and thinning for healthy forest management. It lowered restrictions for people that wanted to do that on private land. And then California State Senate Bill 332, also in 2021, increased access for private and public foresters to acquire permitting for this. But at this point, now since a lot of restrictions have been lifted, we just need to get the word out there. People actually need to start doing this in order for it to actually work. Yeah, so